This video is going to go through a couple quick examples from the worksheet from Friday. Hopefully that helps you for the quiz. So here I'm going to choose an example. Let's do C. Here we go. So this one's asking me to find the value of the discriminant. So I need to identify my A value, my B value, and my C value, just like we did in the Kahoots. And then my discriminant is going to be B squared minus 4 times A times C. Here I'm going to get 1. I'm subtracting this term. I only have one negative sign. So I've got 16 times 5. 5 times 1 is 5. So this is going to give me 1 minus 80. So my discriminant is minus 79, which is less than 0. So therefore, I can say that there are no real roots. Okay, question 6 is asking for the values of P such that the equation has 2 different real roots. So let's take a look at 6a. So I'm always starting off the same way. I'm going to identify my A value, my B value, and my C value, which in this case happens to be P. The next thing that I'm going to do is find my discriminant. So B squared minus 4 times A times C. And I know that I'm looking for 2 different real roots. This tells me that my discriminant is greater than 0. So this expression that I've created here, my discriminant for 6a, I know that that has to be greater than 0. So here I'm going to get 16 minus 4p has to be greater than 0. And now I have an inequality that I can solve for p. So I'm going to rearrange just like I would an equation. Moving the 16 over to the right-hand side is going to change that to a negative. Now the last thing that I need to do to solve for p is divide both sides by -4. Anytime you divide by a negative with an inequality, that is going to flip the equal sign. So that tells me that any p value that's less than 4 would give me a discriminant that is greater than 0, which would give me 2 different real roots. I'm going to do an example for k. Let's try this one. Here my k is just in a different spot. So my approach is still the same. I'm going to identify my values. B happens to be minus 2k. C is 5. And I'm going to start off by setting up the discriminant. So b squared minus 4 times A times C. And I'm looking for 2 equal real roots. That tells me that D has to be equal to 0. So I'm going to simplify my expression here. I'm subtracting. I've got 12 times 5, which is 60, equals 0. And then I'm going to solve this equation for k. So this is going to give me k squared equals 15. So then I would get k equals plus or minus 15, root 15, excuse me. So for either of those 2 k values, plus root 15 or minus root 15, my discriminant would equal 0, which would make my expression a perfect square, which means that my quadratic function would have 2 equal real roots. Okay. Last one, let's look at, let's see, let's try this one with an A value. So we'll try C again. Here, I'm starting off the same way. I'm identifying my A value, which is 3m, my B value, which is minus 8, and then my C value, which is 1. And then I'm going to set up my expression for the discriminant. So B squared minus 4AC. Here I'm looking for no real roots, so my discriminant has to be less than 0. So then I'm going to expand my expression. I've got minus 12m has to be less than 0. Rearranging, just like I would an equation, is going to give me this expression in terms in m. just like the example we did in 6, I'm dividing both sides by a negative value. So that is going to flip my inequality. And I'm going to get 64 over 12, which I think I can divide both by 4. So I'm going to get about 16 over 3. So if m is greater than 16 over 3, that's going to give me a discriminant of less than 0, which means that my equation is going to have no real roots.